Welcome to the fifth and the final part of our Rubik's Cube creation series in Blender Geometry Nodes. In our previous sessions, we started from a simple cube and slowly transformed it into a complete procedural Rubik Cube system. We created the cube structure using instances, built control layer rotation, introduced simulation nodes, solved the rotation memory problem, created dynamic named attributes, expanded the logic of rotation to all the 6 sides, and finally added procedural face colors and materials. Now in this final part, we are going to give the Rubik's Cube its finished look and turn it into a complete animation project. At the moment, our cube has colors and working rotation, but visually it is still very flat. So first, we will improve its appearance by adding face extrusion using geometry nodes. We will use nodes such as extrude mesh and scale elements to create a raised sticker-like surface on each cube face. Then we will assign a dark material to the extruded edges, giving the Rubik's Cube that classic black border look. After that, we move into one of the most interesting parts of this lesson, automatic scrambling. Until now, if we wanted to scramble the Rubik's Cube, we had to manually change rotation values one by one. But today, we will use a repeat node to repeat our 6-axis rotation logic. We will use a math multiply node so that every repeat moves in clean steps of 8, giving us proper 90-degree Rubik's Cube turns. This means our cube will no longer be just a static procedural model. It will become a controllable procedural system. Then we will create a simple animation by adding keyframes in different axis rotation values. Step by step, the cube will rotate across multiple sides, showing the complete logic we built throughout this series. And finally, we will also look at how the same modeling and rotation concept can be extended into a browser-level interactive Rubik's Cube application using Three.js. This is where you can see the bridge between Blender procedural modeling, game logic, animation, and web development. To complete the project, we will also attach a small identification script so that each student's submitted Blender file can display their roll number and name. This helps verify project ownership and makes the final submission more professional. So in this final session, we are not just finishing a model, we are completing a full procedural system. A system that has structure, colors, rotation, memory, scrambling, animation, presentation, and submission identity. Let us now begin the final stage of our Rubik's Cube project and bring everything together into one polished, animated, and complete Blender geometry nodes creation. Let us now start by launching Blender. So I have the Blender shortcut. I will double click to launch Blender. I am in version 5.1.2, and in our previous session we had concluded with our 4_Rubik_cube.blend file. If you are continuing from the previous session, you can open this file and start working on it. If you have directly come to this video, then in the YouTube video description or in the e-learning page, you have a Patreon page link. Click on that link, go to the Patreon page, and there you will find this file. You can download it, you can open it. I will click on this 4_Rubik_cube.blend file to open it. Right now, my Rubik Cube appears very pale. To make it more colorful and attractive, I want to add some extrusions on the faces of this cube. And we are going to add this extrusion using nodes. So I will come into the geometry node, zoom out. On the left hand side, in the previous session, we had added all these 6 color. I am going to select this entire lot, leaving this set material. I select all other and I will drag it a little and I will create some space. So all the nodes before set material are moved. Now I will press Shift+A and in search for extrude mesh. So I have this extrude mesh node. I will click to add it and I will add it before this set material. So once I add it, If I zoom out, you can see that all the faces here are extruded by a value of 1. This is the offset value. I can move it and I can extrude all the faces like this. I will set the offset value to 0. Next, I will press Shift A and I am going to search for a node called as Scale Elements. I am going to select the scale elements and bring it next to the extrude mesh. The mesh is connected to its geometry, and then you have top. I am going to select this top to the selection. As I drag, so I will slightly zoom it and show it to you. It is going to create an inner scale. I am going to set it to 0.8. This is similar to the Inset tool that we use in Blender when we work in edit mode. I will select this extrude mesh, press Shift plus D to duplicate it, and I will place next to scale elements. And in this case, I am going to offset it, and as I offset it, you can see how it is moving. I will set it to a value of minus 0.08 and press enter. So you are seeing a slight amount of extrusion on all the sides. I want all these extruded faces to have a black or a dark material. I will come into the shader editor on the left hand side. I already have color match, so I will click on this new material icon and I am going to call this material as black. I will come into principled PSDF. I will select this attribute and I will delete it, and in the base color I will click and I am going to select a black color. I will click outside. I have set a black color. I will drag to the right and I have set material here. I will select this set material, press Shift D to duplicate, and I will place it between extrude mesh and this final set material. I am going to set this value to black. I am going to drag from the extrude mesh top and I will connect it to the selection. Now you can see my Rubik cube has a black extrusion all around. I find this extrusion to be very large, so I will reduce it. Instead of minus 0.08, I will make it minus 0.04, and this appears to be fine. I have a black extrusion all around, and now I will just zoom out and rearrange it. I will select this entire black of nodes. I will drag it close to my set material. I will select all these nodes and I will move it close here. We have successfully created an extrusion and have allotted black color to it. I will go to File, Save As. I will name this as 5_Rubik_cube and click on the Save button. As of now, my Rubik cube is completely solved. And if I want to scramble it, I have to manually rotate it along different axes here by 8 unit, and I have to scramble it. So I will press Ctrl Z to undo. Now instead of that, if I want to scramble this randomly, I am going to use another node set which is called as the repeat node. I will select all these 6 axis nodes that we have created and placed in between simulation. I will drag a box and I will select, and I am going to press Shift D to duplicate and place it down. I will just zoom out a little. I will select this entire simulation node and geometry output, and I will drag it right to create some space. I am going to add another simulation type node which is called as repeat node. Press Shift A, I will come into search and I will search for repeat node. And just like simulation node, repeat node also has input and the other is the output. If I select both of them, drag it, so I will take the geometry output from my instance on point and connect it to the geometry of my repeat node. I will take the output and connect it to the geometry of the simulation node. I will select this repeat and I am going to create a gap here. I am going to select all these duplicated 6 axis rotation node groups. I will drag it and put it inside my repeat node. I need a little more space, so I will select repeat and move it a little to the left. Then I will draw a box and select all these nodes and put it. I will take the repeat output coming here to the geometry and I will connect it to the input here, and I will take the output from the last one and connect it to the geometry. In repeat, you have a feature called iteration. When the repeat happens, every time this should move by 8 values, or otherwise it will not fully rotate by 90 degrees. So to move it exactly by 8 values, press Shift A, and in search I am going to search for this math node. I will bring this math node, and in the math node, instead of add, I will change this to multiply. For the first value, I am going to connect this iteration. So I will take the iteration output from repeat and I am going to connect it to the first value. Then the second value, I will set it to 8. For every iterations, it is going to rotate by 8 units. And then the output from this multiply, I will take it and connect it to all the rotation value of this 6 group nodes. I will connect it to all the 6 here. So the output coming from this multiply, I have connected to all the 6. Now if this is appearing clumsy, I can just rearrange it with shift pressed on your keyboard. With right mouse, drag it, press shift, right click and drag here. A node is created here. Press G and you can now move this. Say I will move it like this. Similarly, press shift, right mouse click and drag it. A node is added. Press G and move this. Shift right click to add a point. Press G to move the point. Press shift right mouse to add a point. Press G to move it. With shift press, right mouse click and drag. Press G and move it. I have the iteration. It is multiplied by 8 and it is applied to all the 6. I will go to file, save it. If I come into repeat and if I change the iteration value, it is now 1. If I make it 2, automatically it got shuffled. If I make it 3, it got shuffled. If I make it 4, say it got shuffled. So I can do this shuffling. If I set this iteration value back to 1, it will be a solved Rubik cube. And now finally, if you want to create this Rubik cube animation, first I have to scramble it. I will come into repeat and add some iteration value. Say for example, I set an iteration value of 4. So it is now completely scrambled. Then I will come to the geometry node panel, move and come into this simulation section. I will come to first frame number 1. For the first z-axis, I will come into rotation value and press I to add a keyframe. I will come to frame number 30 and I will set this rotation value to 8. I will press I again to add a keyframe. At frame 30, in the second y-axis node group, I press I to add a keyframe. I will then come to frame number 60 and in the second group, I will set the rotation to 8 and press I to add a keyframe. I will come to node group 3, come on the rotation, press I to add a keyframe. I will then come to frame number 90 and I will set this third group rotation to 8, press I to add a keyframe. I will come to fourth group, press I to add a keyframe. Then I will move to 120. I will set the fourth group value to 8, press I to add a keyframe. Then I will come to the fifth group, press I to add a keyframe. Then I will come to frame number 150 and I will set this value to 8 and press I to add a keyframe. I will come to the sixth group, press I to add a keyframe. I will move to frame number 180 and I am going to set this to 8. I to add an animation, and here in the end frame I will set the animation up to 180 frames. Now if I rewind and if I play it, you can see I have successfully created this Rubik cube animation. So you can see the Rubik cube rotating on all the axes. This was one of the most complicated way of calculating and making this Rubik cube animated. The same concept is used and we have developed web application. I have shared this link to you. This runs in your browser. There are two buttons, solve and scramble. So if I click scramble, see automatically it is going to rotate, and then to solve it, see you have keyboard shortcuts. So if I press U on my keyboard, the upper part rotates forward. If I press Shift U, it rotates backward. See, I can press U, then I can press D, then I have R to rotate on the other axis, L for other axis, F for other axis, and B for other axis. So I have U, D, R, L, F, B as the keyboard shortcut to rotate in 6 axes. So this application has been developed using the modeling technique that we used in Blender. How to create these buttons, how to add this solve and scramble, this is a completely another part of this development. Here we are using Three.js. We are going to discuss this about later when we discuss about the Three.js. Come to your Blender file, stop the playback, rewind, go to file and save it. To avoid plagiarism and see that the students do their job themselves, I am going to attach a script to it. You can come to scripting, coming into scripting, come into text, open, download this identify.py file. I have provided this file both on Blender Studio and it is also on the Patreon page. You download it and open it and you have a small script. Welcome to Rubik Cube by, here you put your roll number. This is designed by, you have Dr. Sudhindra SG name, you replace it with your name, then go to text, save it, and then you have an option here, register. Now click on this register. Now if you save this, if you close Blender, click save and close the Blender. Whenever you send this file to me and when I open this file, when I click File Rubik Cube and open it, you have a warning here. If I click on allow execution, you can see this pop-up appearing showing your roll number and your name. This way I can identify who has submitted the project. Save this Blender file and upload it on Blender Studio or on Google Drive and share me the link. So this completes our second project where we have worked on this Rubik Cube.